What I've got here is a little solar light. So it uses a screw-in glass type container. So it actually screws in like that. And that fits, the cap fits over like that. Right. Bottom end the spike goes in, it sits like this in the ground. Now in the top, you got two LEDs. You got a color changing one, which is the RGB, or you can have just warm white, like that. So let's have a look at the circuit. I'm currently running it off a power supply, and the battery that's installed in it is this little 300 milliampere hour 1.2 volt nickel metal hydride. Let's have a look at the circuit. Zoom you down a little bit. Right, I think you've got a good view. So let's start off with the board quickly. The board looks like that. On the back you got the all-in-one chip, capacitor, the rectifier, diode, 3 components. On the other side there's a switch and the inductor and the battery terminals. On the cap there's a wire into the LEDs, and then the other side of the LEDs looks like that. Now the LED, you got your positive over here, it's SMT RGB LED, color changing. There's a control chip, so you got a wire coming in here, it's a 5-pin chip. There's your 0 volts going to this pad. There's your 3 LEDs. So you got 3 wires going to each LED and your 0 volts. And there your LEDs, those outer LEDs have got wires connecting them to the 0 volts. Then the middle LED uses the ground plane for 0 volts. That's what it looks like inside. Alright. The circuit. These days they use an all-in-one chip. So the solar cell, a 1.5 volt solar cell or 1.4 volts, goes into the chip. So that's your daylight sensor as well. So the chip takes care of the charging and the control of the turning the thing on when it gets dark. Google says it doesn't know about that chip, which we're used to these days. So how it works is, when you connect the switch like so to the battery, the switch in either position, RGB or warm white, RGB warm white, connects the battery, okay. And this chip has always got power on it because of that. Once you've connected that switch and it becomes dark, what the chip then does is it fires this output pin over here, takes it low and then lets go. Pulses look like that. It then charges up this capacitor through the Schottky diode, and that then powers the LED depending on which one's in circuit through the switch over here. The inductor is 47 microhenry. So it's yellow, purple, black, silver. Those are your color bands on it. The capacitor is 100 nanofarads. I looked to the scope. It's 300 kilohertz that it's switching over here across the inductor. So the inductor's got positive on it, and it takes it low. Then when it lets go, that then charges up this diode over here. Because we've only got 1.4 volts over here, what's happening when it lets go is that it charges this up to a higher voltage of 3.56 volts, which is your forward voltage across an LED over here. And that is pretty much what's going on here. They've become all in one these days as regards these chips. Charge control, dust control, the switch mode regulator, that sort of stuff. So if one wanted to change your LED color intensity, you could change that inductor value. And I think that's about it. The top of it looks like that. And there's your solar, here's your 3. Strange that that one is sort of half a cell. I measured it, I'm getting 1.4 volts out. And there's your LEDs over there. Like that. So RGB, warm white. And the current that I'm measuring on the power supply with which I'm feeding this is 20 milliamps. Right. The effect when you have that screwed onto that is not bad. Let me turn it on. You can see what it looks like at night. Now make things dark here. Turn a few things off. Turn off some more lights over here and over here. Alright, there you go. That's what that light looks like at night. So just warm white looks like that. So it faces downwards. It's quite a nice scatter light from the frosting on the glass. And then there's your RGB over there, like so. Also quite a pleasing effect. It just sits slowly changing color. Nice. The light's coming back. Alright. So that is it. These are available at Walmart, our local Walmart. A little cheapy solar light, but it works. And it's quite pleasing, and this is straightforward stuff over here. And I think you now know exactly what's going in here. We did a nice reverse engineering here, got all the values and so on. That's what you find inside them these days. Textbook stuff. Well made, does the job. And I think they're cheap. Like $5 or so. Really cheap stuff, but it does the job. Right, I'm going to wrap it up here. Thanks for being here and watching the video, ladies and gentlemen. Take care. Have an awesome day further, and I'll see you next time for more stuff. Cheers.